Hello, this is Mr. Collier, and today we're going to show what the general formula for the area of any regular polygon is. So we're going to start with some random regular polygon. We have a regular octagon here, but let's pretend for a moment that we don't know the number of sides. It's just a general random regular n-gon. Okay. So for any regular polygon, you can get the area by drawing a triangle in here. Okay, you can always get an isosceles triangle in a regular polygon, then multiply by the total number of sides, and you get the area of the regular polygon. But we're going to do that in general, so we're going to start with this triangle that we have. I'm going to make a larger version. Okay, and let's call the side length of our n-gon, let's call it A. Okay, so in our little triangle here, we're going to have, well, this is half A. This distance is half A. We'll call this angle theta. And we're going to try and find the height of this triangle here. Okay, so I'm going to call that x for now. Alright, so what we're going to do is we're going to actually find a measure of theta first. If we have an n-gon, then the measure of any exterior angle is going to be 360 divided by n. Right, that's how you find the measure of an exterior angle of a regular polygon. If you want to find the interior angle of a regular polygon, you have to take 180 minus 360 out of n to get this angle. So that is equal to theta. So theta equals 180 minus 360n. Well, actually, that doesn't equal theta. Theta is half of the interior angle of the regular polygon. So this is equal to twice theta, and theta is going to be half of that. That's going to be 90 minus 360 divided by, oops, that's going to be 90 minus 180. 90 minus 180 degrees divided by n. So that's our value of theta. And if you want to find x, we can use the tangent function. Tangent theta equals x divided by half a. So I can multiply both sides by half a. Okay, multiply both sides by half a, I get x equals half a tan theta. Okay, we'll plug in the value for theta later. Okay, so we have the value of x, we have the value of the bottom part of the triangle. Let me just redraw it again, what we have here. So this is A down here, and we know that this side here is half a tan theta. So I can get the area of one triangle. Area of one triangle is half times base times height, which is half times a times half a tan theta. Okay, and that's going to be, so that's going to be a quarter a squared times tan theta. And if we've got n sides altogether, we need to multiply this by the number of triangles, which is going to be n. So the area of the regular polygon, or I'll call it area total here, it's going to be equal a quarter, n times quarter, or a quarter, let's write n out of a quarter. Now let's write it like that. N out of a quarter times a squared times tan theta. Now let's reduce this tan theta over here actually. So we have half a tan theta, and theta is 90 minus 180 out of n. then that's going to be half a, and 90 minus some value gives us cotangent of that value. So this is going to be cotangent 180 out of n. You can verify this yourself. This is a trig identity. So we have half a cotan 180 out of n. Or if you're using radians, you could use pi over n. So that's equal to x. And I'm going to, actually we don't need this part here. We can just say that tan theta equals this amount and put that into the tan theta over here. So we're going to have the area of any regular polygon is quarter times n times a squared and cotan 180 out of n. Okay, you can verify that on a calculator with a square or a pentagon, and you'll see that this works every time. This is a general formula for any regular polygon.